Welcome to This Explainer. Have you ever just stopped and wondered why some objects are an absolute joy to use, while others make you want to literally pull your hair out? Well, today, we're going to demystify the invisible rules that govern our everyday interactions with both digital technology and the physical world. It's kind of like an invisible art form, and honestly, once you see it, you will never look at your everyday objects the exact same way again.
I mean, we've all been there, right? You're standing in a public restroom, waving your hands frantically under an automatic faucet that simply refuses to turn on. You feel a little ridiculous. But let's dive into this because there's actually a really liberating truth here. When you struggle to use an everyday object, user error is almost always a design error. Seriously, it's not you, it's the design.
So to truly understand these daily frustrations, we need to look at what are called design principles. You can think of these as generalizable abstractions. Essentially, they're the invisible rulebook dictating how we interact with systems. They help orient designers toward creating things that work in harmony with human psychology, rather than fighting against it.
And it all boils down to 6 core principles of human-computer interaction: visibility, feedback, constraints, mapping, consistency, and affordance. Master these 6 concepts, and you're going to hold the key to understanding exactly why your favorite apps feel like pure magic and why that one door at your office is always so confusing.
All right, first up is visibility. This principle simply states that the relevant parts of a system absolutely must be easily perceivable. Important controls and info, they should never be hidden. When visibility is done right, it lets you immediately understand what your current options are and exactly what the system is doing behind the scenes.
Just look at how visibility plays out in digital design. On one hand, you can have a navigation menu that's crystal clear, with large, well-contrasted icons and text that makes it incredibly easy to find what you need. But then, compare that to a completely confusing, cluttered nightmare where essential elements are practically hidden in the background. It's exhausting just looking at a bad interface, isn't it?
But wait, this failure of visibility happens in the real world constantly too. Just look at these elevator buttons. They're placed so ambiguously between the floors that you literally cannot tell which button triggers which floor. Are you going up? Down? The system is completely failing to make the function of those controls visible to you.
In fact, the design failure here was so extreme that it required human intervention. Someone actually had to take a sharp tool and physically scratch lines into the metal panel just to connect the buttons to their corresponding floors. They had to force the system's functions to become visible. And, when users have to literally vandalize your product just to understand it, your design has absolutely failed.
Going back to that automatic sync from earlier, if a faucet requires a massive multi-line paragraph of text physically printed on it just to explain how to get water, visibility has entirely failed. Without that text, a user would have absolutely no clear indication of how the thing even works.
Moving right along, our second principle is feedback. Basically, every time you interact with a system, the system should talk back. Feedback provides you with clear and immediate confirmation on your actions so you understand the outcome. It's the system's way of saying, hey, message received, I'm working on it.
You see this constantly online. Good feedback takes the form of those familiar loading spinners, progress bars, and percentage indicators. When you submit a web form, a progress circle immediately assures you that the system is processing your request. Without it, you're just left staring at a static screen, guessing if your click actually worked or if you're going to have to hit submit a second time.
Actually, think about the everyday feedback you rely on without even noticing. Why do digital buttons on your screen animate with a visual pushdown effect when you click them? Or why does your telephone touchpad beep out loud when you press a key? It's all highly engineered feedback, designed to confirm your interaction instantly.
Okay, let's talk about our third principle, constraints. Think of these like protective guardrails. They work by purposefully limiting the ways in which you can interact with a system to prevent errors or confusion. They're silently, safely guiding you toward the correct action.
A perfect example of a digital constraint is a phone number input field. A good design strictly restricts your input to numbers only, giving an immediate error if you accidentally type a letter. A bad design? It lets you type letters and special characters, setting you up for a super frustrating error message only after you've tried to submit the whole form.
And physical objects use constraints brilliantly too. Imagine computer ports that all look identical. It makes it incredibly easy to plug the wrong cable into the wrong slot. But by utilizing distinct color coding, like green for a mouse and purple for a keyboard, along with specific pin shapes, the design physically constrains you. It practically forces you to plug the right cable into the right port.
You know those grayed out options in software menus? If you open a dropdown and see certain choices are faded out, that's a constraint in action. The software is telling you those actions just aren't available right now, constraining your interaction to only the valid choices and saving you from useless clicks.
Which leads us perfectly into principle number 4, mapping. Mapping is all about predictability. The relationship between a control and its resulting effect should be entirely logical and intuitive, usually based on how things are spatially laid out in the real world.
For instance, turning a volume knob clockwise to raise the music just feels natural, right? It maps to our spatial understanding of up or more. On the flip side, having a bank of light switches on a wall with absolutely no logical connection to the layout of the lights on the ceiling is a terrible mapping failure. You're just left guessing and flipping switches at random.
All right, principle 5 is consistency. And this one is really about respecting your time. Good design dictates that similar icons, navigation schemes, and interfaces should maintain the exact same appearance and location. Basically, you shouldn't be forced to relearn an app's interface every single time you jump to a new screen.
Think about the classic QWERTY keyboard. It's the ultimate example of consistency across the globe. You can sit down at a laptop, a desktop, or pick up a smartphone, and you know exactly where the letters are. Imagine the sheer frustration and loss of productivity if every device you owned featured completely randomly placed keys. No thank you.
But here's a fun quirk. Consistency can sometimes vary across platforms. Look at standard number pads. A phone dialer starts with 1, 2, 3 at the top, but a computer number pad or a calculator, those start with 7, 8, 9 at the top. This is exactly why you might briefly stumble and hit the wrong key when switching your brain from dialing a phone to doing math.
And finally, we've made it to number 6, arguably the most profound principle, affordance. Affordance states that the design itself should silently communicate exactly how it's meant to be operated. Its physical properties, its shape, size, and location should instantly suggest its function without a single word of instruction.
We have absolutely all been betrayed by a broken affordance, most famously with doors. A flat metal plate on a door visually affords pushing. You literally cannot pull it. But if a door presents you with a prominent vertical bar handle to pull, yet the door actually requires you to push it open, the design has lied to you. It's a broken affordance, leading to that awkward moment where you pull, crash into the glass, and feel totally foolish.
And that brings us full circle. Armed with these 6 core rules of human-computer interaction, visibility, feedback, constraints, mapping, consistency, and affordance, I challenge you to look at your world through this new lens. Try to spot the bad design hiding in plain sight in your own home or office. What object around you right now is breaking these rules and making your life just a little bit harder? Find it and know for sure that it's the design's fault, not yours. Thanks for joining me on this explainer, and keep your eyes open.